36 cube. That will be a huge task. Of course, you do not want to spend too much time on it. So what slight change will you make in your answer so that you are almost close to the volume of the new edge? Correct? So that is what we are going to learn now. So without recalculating the entire y, how to make these minor adjustments to get an approximate new value. Right? Please note, smaller the value of delta x, more closer you will be to the answer by this method. Right? So the error has to be as small as possible for you to reap the maximum benefit from this method. Listen to this, sometimes it is very useful in doing your chemistry calculations also. Now from here, if I want to know how much adjustment should I make in y, can I say I can just send the y on the other side? Correct? And y itself is f of x. So can I replace this with f of x? Correct? Now divide by delta x. Both sides.
Oh, this is limit.
And take your delta x to be tending to 0. That means your error should be very, very small. So when you do that, you realize that your right hand side becomes f dash x by first principles. Correct? So we say delta y by delta x, when delta x is tending to 0, will be nothing but dy by dx calculated at that x where the error has occurred. This is important. So you need to calculate dy by dx at the point where the error has occurred. Let us go back to that example. So initially when you calculated the volume of the cube, when x was 2, your volume came out to be 8. Correct? But later you realize that no, my x was not 2, it was actually 2.0036. Correct? So how should I know what is my new volume or what is my error in the volume? Correct? So at least if I know this, I will add it to 8 to get my answer. Correct? So what you will do, you will use this formula, you will say delta v by delta x will be, now here I would use the word approximate because delta x is not exactly tending to 0, it's a good amount value. So you can say it is approximately dv by dx calculated at which x? 2. Correct? So delta v is something which we are looking out for, we don't know that. But we know delta x. Delta x is how much? If you take the 2 on the other side, it will be 0.0036. Right? And what is dv by dx? 3x square, and that too you are putting x as 2 here. So what will it become? 12. So delta v by 0.0036 is 12. So that means delta v is 12 times 0.0036. How much is 36 into 12? 72, 36, so 432. So can I say it's 0.0432? Correct? So your new volume would be V plus delta V, which is 8 plus 0.0432, which is 8.0432 centimeter cube. So I never sat and did 2.0036 whole cube. I just saw how much adjustment I have to make to my volume or what is the error introduced in the volume and adjusted it with that error. Okay. By the way, I would request you to take out your calculator if you have and just check if I do just 2.0036 whole cube, how close am I to the answer? Very close. How much is it? How much is the actual?
3.043277.
See, it's almost very close, right? Right? And you will be more close had this error been very, very small. Right? As the error approaches 0, delta v by delta x will approach dv by dx. Is the idea clear? Okay. So, I am achieving two things here. I know the error first of all. What is the error in the output? And I can approximate my new value by adjusting the error. Okay. So basically this is the theory involved in errors and approximations. So now we'll take various type of problems on this. Any questions with respect to theory? Any question? Jagran, Ashwini, clear? Alright. We'll talk about relative error, percentage error as well in some of the questions. Meanwhile, can I erase this? One more thing to be kept in mind. Many people, they ask me, sir, how did you know that I have to add delta x, not subtract delta x? Or how do I know I have to add delta v, not subtract delta v?
You get delta v as negative.
Let me tell you, delta v is always added. Had the need been that you have to subtract something, delta v will automatically come out to be negative. So you do not put an external sign to it. Delta v or delta y will automatically come with its own sign. You always have to add it to the previous value. So it's always y plus delta y, it's always v plus delta v, it's always x plus delta x. Right? So many people ask, okay, now you knew that the cube is increasing, so you added it up. Had the cube been decreasing, you would have subtracted it. No, I still would have added it, but delta v would automatically come out to be negative. Okay. So you do not assign any sign externally. Oh, sorry, do not assign any sign randomly to the delta x or delta y thing. Let's take questions. Let's take a question. Find the approximate value of cube root of 127. Find approximate value of cube root of 127.
So this was the original x, this is delta x. So if it was 125, what would have been y? And now it is 127, what is my error in the y and add it to y?
How much? 5.026. 667.
0167.
0167. Okay, let's check. Okay, first of all, I need to make a function here. The function here is clearly y is equal to x to the power 1 by 3. Had your x been 125, my life would have been much simpler, right? Correct? Now, why did I choose 125? Why didn't I choose something like
Because 125 is the nearest.
right? So basically, I need to make the error smallest as possible.
So you can also take 128 just to keep us 7. But that
128 cube root is known.
128 cube root is 8 root 4.
Okay, so find such an x whose cube root forming is very easy. Whose cube root finding is very easy, and should be very close to this figure. Right? Don't choose 64. Right? The more distance you go from this, the approximation will be bad in that particular scene. Right? So take it very close to the value actually given to you in the question. So the closest that I can have is 125, which is a perfect cube root. Correct? So had x been 125, my answer would have been 5. But because of some issue, it was not 125, it was 127. Correct? Which clearly implies the absolute error was 2. Okay. Had it been 120, let's say 4, it would have been minus 1. Delta x would already be a negative number. Okay. Now because of this delta x, what is my delta y? And hence what is my y plus delta y? That is what I need to find out. Okay. So now I will use the formula delta y by delta x is approximately dy by dx at the point error has occurred. Okay. So delta y is not known, delta x is 2. This is approximately equal to dy by dx. What is dy by dx? 1/3 x to the power minus 2/3 at 125. Can I say this is 1 by 75?
Yeah.
Okay. So delta y would be 2 by 75. Right? How much is that 2 by 75?
0.0266.
10266. Yeah. It's actually a bar. Correct? Okay. And if you want to be very close to 4 decimal places, you can say 02667. Okay. So the error in the y is 0.02667. So the new value, which is what I desire, this is actually my y plus delta y. So the new value will be the previous value 5 plus this correction that you need to make. So just use your calculator and check whether we are very close to it or not. Okay. So this is how, without actually calculating it, you can solve your problem. Now don't think that you have actually become a calculator because by this method. Your question should be very close to the known values. So if I give you 140 cube root, then only you will be struggling. The answer will not be very accurate. So in those circumstances where there is an error and you think that had it been 125, I would have calculated it, then you can use these kind of
What if the
approaches.
margin is too big? What if the margin is too big?
Yeah, that's what.
Those questions will not be asked. Okay. Alright. Let's take one more problem on approximate values. Should I erase this? If f of x is x cube minus 7x square plus 15, find f 5.001. find f of 5.001.
Minus 34.000.
Minus 34.995. That's the answer.
You subtracted 0.005.
Minus 34.995.
So they will give a question which will make sure that there is a nearest number which contains the power, which can be evaluated.
See, yeah. See here, if your x was 5, you would not have any problem calculating f5, right?
Yeah.
f5 would have been simply 5 cube minus 7 into 5 square plus 15. How much is it?
Minus 35.
125 minus, how much is it? 25 into 7?
175.
Minus 175 plus 15, which is minus 35. Correct? So y would have been very simple had your x been 5. But because of some error, you'll have to check the new value. So now here error is 0.001 plus 0.001. So we'll use the formula that change in the value of the function by changing the value of the input parameter is approximately dy by dx calculated at where the error has occurred. So delta y not known to us, delta x is 0.001. This is approximately equal to the derivative of this, which is 3x square minus 14x calculated at x equal to 5. So if I am correct, this is going to be 75
Minus 70.
75 minus 70, which is 5. So delta y would be 0.005. So your new value of the function, which is f of 5.001, will be the previous value plus delta y, which is plus 0.005. Hence your answer will be minus 34.995. Moving on to questions based on percentage error and of course relative error. So far you would have realized that things are going pretty smoothly. This chapter is indeed very easy.
Sir.
It's very scoring part. This 5 chapters is very scoring. Yeah. Application derivative is very scoring. Shriram, clear? Let's move on to questions based on percentage error. This one. On the same concepts. You want absolute error problem? I want another problem. Okay. So
a tough one.
This is actually an advanced book. Yeah, find under root of 0.0037. Find under root of 0.0037. They can give you various types of, it's not only squaring root or cubic root, they can ask you cos of 60.1 degree. Or they will say log of 4 is this much, how is log of 4.01? So any kind of operation can be made. Alright, first of all, let's see which is the function that is responsible here. The function is root of x. Correct? This is something which you have to find out. Nobody will tell you what is the function involved. Correct? Now tell me, what is the suitable value of x close to this number for which y can be easily be found out? 0.0036. Correct? So had x been 0.0036, my answer would have been 0.06. Correct? So life would have been very easy. But Bhagwan ko ye manzoor nahi. So he made 0.0037. That means the error was 0.0001. Right? So what is my delta y, and that is what I need to find. So I will use the approximation delta y by delta x is dy by dx calculated at x equal to 0.0036.
Sir, 0.06.
Oh my bad, sorry. 0.0. No, it's correct.
00, yeah.
0036. At that x where the error is occurred.
Yeah.
So 2 root x and put x as 0.0036. So if I am not wrong, this will give you 0.06 here. Okay. And take this delta x on the other side. So delta y will be this into delta x, which is 0.0001. Too many zeros. So is it coming out to be 1 by 120? So yeah, sorry. Okay. So this is 0 point means 0, again a 0, again a 0, again a 0 and 83. Correct?
Yes, sir.
Correct?
Yes, sir.
Now, this is the change in the y value. So my new y value will be y plus delta y, which is 0.06 plus 0.00083, which is 0.06083. Don't get muddled up with the zeros, so many zeros. Okay. So in another 15 minutes we will take up these relative error questions and then we can go for a break. Fine, clear? Next, time period of a simple pendulum is given by 2 pi under root L by G. Time period of a simple pendulum is given by 2 pi under root L by G. Okay? All of you are aware of this formula?
Yes.
Find the percentage change in time period. Find percentage change in time period if the length of the pendulum is decreased by 1%. If the length of the pendulum is decreased by 1%. Just 1 minute, yeah. So how do we solve this? Again, we make use, guys. Just one. Yeah. Now we use this formula. dt by dl is approximately delta t by delta l. Correct? Now what is given to us in the question? Question mentions me delta l by l into 100, which is how much? Minus 1. Minus 1. It's a decrement. And the question is asking me what is delta t by t into 100. This is what the question is asking. Correct? So I will use this fact that delta t by delta l is approximately equal to dt by dl. Correct? So what I will do, delta t by delta l, I will differentiate this with respect to l. So it's 2 pi under root of g and derivative of root l is 2 root l. Correct? Is this okay? So this term I have